In 8.1, we'll be talking about a formula called the law of sines, and we use this to solve triangles that are not right triangles. They're called oblique triangles. And when you solve a triangle, that means you find all the missing sides, all the missing angles. So we'll also find the area using sine, and we're going to solve applied problems using law of sines. So we use the law of sines in one of three instances. The first one is angle side angle. That's when we know two angles and the included side. Okay, this word included means between. My line right here is between angles A and B, or C, excuse me, that's gamma. We have angle side, okay. Angle, and a non-included side. Non-included means not between. So these are our two key instances where law of sines is going to be spot on, easy peasy lemon squeezy. Then we have this something called the ambiguous case. Okay, that is side angle. This one's a little different than we know two sides instead of two angles. We have our side here, we have another side, and we have a non-included angle. This presents a problem because that third side right here, the side that we don't know, could cause one triangle, two triangles, or not at all. And we'll get to that here in a minute. So how do the right triangle relationships set up the law of sines? So given a triangle with angles and opposite sides, the ratio of the measurement of an angle to the length of its opposite side will be equal to the other ratios. So this is what I mean. All right, I'm going to draw a right triangle, or a non-right triangle, excuse me. Making it actually a triangle. We're going to call this angle A, angle B, angle C. So angle A, angle B, angle C. If you want to use alpha, beta, gamma, that is fine. All right, the side across from angle A is little a, from angle B is little b, from angle C is little c. What it's saying is if I take the sine of this angle over A, it's going to equal the sine of this angle over B, which will equal the sine of this angle over C. Then, of course, we can do the reciprocal. So we don't typically use these at all. We use that one. Our first two examples are examples of angle side, and angle side angle. We know two angles and one side. All right, so I'm going to look. I have angle A. I'm going to rewrite this as capital A, capital B, and capital C. All right, I've got angle A. So angle A, side A. I do not have angle B, or side B. I do have angle C, but not side C. So I'm going to actually start with angle B. If you know two of the three angles of a triangle, we find the third one by subtracting them both from 180. So angle B is 180 minus 50 minus 30. Angle B is 100 degrees. Awesome. I'm going to go ahead and write that over here. Angle B, 100 degrees. What's left to do is to find our two remaining sides. I don't care which one you start with, side B or side C, it does not matter. You'll start it the same way, by using the angle and the side that we do know. So the first half of my proportion, using law of sines, sine 50 degrees over 10. Sine A over A. Let's say we find side B first. So that's going to equal sine 100 over B. Cross multiply. B sine 50. 10 sine 100. We're going to divide by sine 50. And we're going to divide by that because sine 50 is a number. I don't know what it is, but I know it's a number. And then that goes in your calculator. And you want to make sure that you are in degrees. So I'm in degrees. All right, so do my fraction. We've got 10 sine 100 over sine 50. We got 12.856. And the directions say round to the nearest tenth, so that'd be 12.9. All right, remaining side, C. Start with what we know. We know angle A, side A. 50 degrees over 10 equals sine 30 over C. Cross multiply. You'll see me kind of shortcut it a little bit by only writing the division on one side. So C equals, I'm going to put that in the calculator. Ten sine 30 over sine 50. 6.527. So the nearest tenth would be 6.5. Our next example, angle, side, angle. Angle, side, angle. So we know two angles. And one side. Order doesn't really matter on that one. I'm missing angle B, so just like I did on the previous example, I'm going to find angle B by doing 180 minus 98 minus 43. Minus 98 minus 43. I'm doing this in my phone calculator. Equals 39 degrees. All right, so I'm going to go ahead and write these in. A, B, C. B is 39 degrees. That gives me an angle and its opposite side. I don't know 43's opposite side, and I don't know 98's opposite side. But I know B and B. Doesn't matter which one you start with. I'm going to start with A, alphabet. Okay, start with what you know. Sine 39 degrees over 22 equals sine 98 over A. Cross multiply. Divide by sine 39. Calculator. (22) sine 98 over sine 39. 34.618. Now find side C. Start with what we know. Sine 39 over 22 equals sine 43 over c. Cross multiply. Divide by sine 39 and calculate it. And 23.842. All right, so it's to the nearest tenth. So A would be 34.6. C would be 23.8. Now the ambiguous case. Using a law of sines to solve side-side angle problems. The issue comes from what to do with that missing side. All right, so I'm going to show you a clip in the next one. Or attach a clip. You know what? I'm going to attach it because it's a little weird to kind of screenshot that. Let's see what happens. All right, now, I am a big proponent of if someone else has a better way of explaining something, I'm going to 100% use their method. So I'm going to show you a video that explains how it's possible to have one triangle, two triangles, or no triangles at all, and why we use the law of sines, how we use the law of sines for side-side angle situations. I'm not going to show you the whole video, but I am going to show you like the visual. I will also link it in your Blackboard so you can see the entire thing if you need it. Maybe. Where's YouTube?
Teachers teach the ambiguous case in a way that looks like this, or something like this. But here's what I have to say. No, no, and definitely no. I mean, this process right here takes 2 x's to cover up. That's a pretty bad sign. So, for today's crazy calculation, we're going to learn about the ambiguous case, but the easy way. So, what is the ambiguous case? Well, the ambiguous case is when you're given SSA, or side-side angle in a triangle. And when you're given SSA, there can be 1, 2, or no triangles. And why does this happen? The mathematical explanation is that when you're given SSA, you will use law of sines to find another angle, and to do that, you'll use inverse sine. And when you take inverse sine, there could be no answers. For example, if you take the inverse sine of 1.3, your calculator will tell you error because sine has to be less than or equal to 1. Or there could also be 2 solutions, but your calculator only tells you 1. Think about the inverse sine restrictions that you might know about. Your calculator will only give you an angle between 90 and negative 90 degrees, so if there's another solution, your calculator won't tell you that.
Free shipping now on Vinted, which means your next find just got better.
And now, here's the visual explanation. I don't want you to think mathematically right now, just sit back and watch the visuals. So, you're given side-side angle, right? That gives you 2 sides, and I tried to make these look sort of like wood boards to remind you that you cannot change the side lengths of these 2 sides. These are set in stone, you can't change them. And then you have another side, and I just drew it as a line like this, because you can make it as short or as long as you want. You aren't given the length of this side. And also, you're given A, so an angle. Let's say we were given the measure of this angle right here. I'm going to put a lock on this angle to remind you we cannot change this angle right here, and these 2 wooden boards we cannot change the length of. But what we can change is the angle right here and the angle right here. So now to find the triangle or triangles that these 2 legs and this angle can make, what we can do is we can swing this leg back and forth, like this. And now if this side ever touches this side right here at any point, then that means we have a triangle. So if we swing it right here, we get a triangle because it closes off this triangle right here. And also if we swing it right here, we get another triangle. Now as you can see, my model isn't exactly perfect, but let's draw some more accurate versions of these triangles. So the first triangle, if you drew it accurately, would look like this, and the second triangle, when you swing this leg over, would look like this. Now let's look at a different situation using this same model. Let's say our side that we were given right here is a little shorter. And now if we try to swing this side back and forth, it never connects with the bottom, which means there's no triangle. And now let's say this side is a little longer. Now if we swing it, it's just long enough to make a right triangle right here, but it can never make any more triangles. It just makes the one triangle right here. And the reason why it's a right triangle is because the closest distance between a point and a line is always a perpendicular line. So that's why it's a right triangle. Now let's look at one more situation. Let's say this leg right here that we were given was a lot longer, even longer than this leg right here. If we swing it right here, it connects, it makes a triangle, but if we swing it further, it never connects again. So there's just one triangle, and that's this triangle right here. So now you should be able to see how we can end up with one triangle, no triangles, or two triangles. But how are we supposed to know if there are one, two, or no triangles? Well, we don't have to memorize all that stuff that we saw in the beginning of the video that a lot of other teachers tell you to memorize. We just need to test it. Take a look at this example problem right here. Angle A is 140 degrees.
Okay, so I think that's a better example as to why we have these so many options for the ambiguous case for law of sines. All right, so we go at the law of sines with the ambiguous case with the assumption that there are two triangles until we prove otherwise. We test it out like the lady in the video said. Solving a triangle to the nearest tenth. I have angle A, angle B, angle C, alpha, beta, gamma. And I see that I have two sides and a non-included angle. I have side angle. All right, with the information that I have, my given info is angle A, side A. I don't know anything about angle C. I don't know angle B, and I don't know side C. Okay. But I do know side B. So finding this angle will be my first stop. Okay. We're going at it with the assumption that there's two triangles. So we're going to call it B1. Finding angle B1, we use the law of sines. Sine 35 degrees over 6 equals sine B over 8. Cross multiply. And then we're going to divide both sides by 6. And then we're going to take the inverse. And the reason I want the inverse is because I'm not solving for a side, I'm solving for an angle. So I'm finding angle B down here. So we take inverse sine, 8 sine 35 degrees over 6 equals angle B1. And we go to our calculator. Make sure you're in degrees. Inverse sine 8 sine 35 over 6. And I get 49.886. All right, so it says to the nearest tenth, so we're going to do 49.9 degrees over here. Well, that gives me angle B. All right, I can find angle C now. I have 2 of the 3 angles of a triangle. We can find the third one by subtracting from 180. So 35 is given. And then 49.886. So what I want you to see as I put this in the calculator, especially in Desmos, not that one, 180 minus 35. Now in Desmos, but right by the plus sign, you see this abbreviation ANS, answer. That takes the previous answer that you just got, which was the angle. Okay, that helps me with my rounding. So 95.113, 95.114. All right, all that's left is our missing side, C. All right, well, I just found angle C, 95.114. So find side C. Well, fine. 35 degrees over 6 equals sine 95.114 over side C. Multiply. And divide by sine 35. Calculator. I don't know where that's going. Let's see. 6 sine. No, I'm using the 95 that I just got. So I'm going to hit answer here. And then over sine 35. 10.419. All right, since this is ambiguous, the next thing we do is we assume that there's a second triangle. So I almost always put a box right here and title it second triangle. That way I know that all the work that I do inside here goes with the possible second triangle. All right, I started with angle B. I'm going to start with angle B. We're going to call it angle B2. Angle B2 is supplementary with angle B1. So it's 180 minus B1. This is where you want to be really careful with the rounding. Because that example, I don't know if I can go up and highlight it. No, I can't go up there and highlight it. At least I don't think. Nope. All right, so we're going to do 180 minus 49, and I'm going to use my unrounded, 886. So 130.114. All right, now here's the true test on whether or not we have that second triangle. Is angle C2. It's going to be 180 minus 35 degrees. That's your given angle right here. Minus B2. If this angle is positive, there's a second triangle. If this angle is negative, there's not a second triangle. That's literally all there is. All right, so we're going to do 180 minus 35 minus, okay, previous answer. And we get 14.886. That's a positive number. There is a second triangle. Luckily, the only thing that's missing once you do find that second triangle is side C, little c2. Sine, given information, 35 46 equals sine new angle C over C. Cross multiply. Divide. And calculator. Six sine previous answer over sine 35. 2.687. All right, since we did get a triangle, a second one, angle B2 was 130.1 degrees. Angle C2 was 14.9 degrees. And side C2 was 2.7. Solve the triangle to the nearest tenth. So I'm going to adjust A, B, C. I'm going to make this one A. Okay, capital letters, angles, not capital letters, sides. So I am missing angle B, angle A, and side A. So angle B, angle A, side A. The given information is angle C to its side 12. With the information that I have, I can find angle B because I know its opposite side. So we'll start there. I'm gonna call it angle B1. Sine 85 degrees over 12 equals sine B, because I'm trying to find the angle, over 9. Cross multiply. Divide by 12. And take the inverse. Calculator. Inverse sine 9 sine 85 over 12. 48.344. So I got B. Now we can use angle C and angle B, which I know is 48.3, to find angle A. $180 minus 85 minus 48.344. 180 minus 85 minus our previous answer, 46.656. So 46.7. And the last thing I'm going to do is we're going to find our missing side A using law of sines. Sine 85 degrees over 12 equals equals sine 46.656 over A. Cross multiply. And divide. So A equals sine previous answer over sine 85. And we get 8.760. Okay, now, second triangle. Okay, we started with side B, or excuse me, angle B. We're going to start with angle B. So it's 180 minus B1. So 180 minus 48.344. 180 minus 0.344. $131.656. We can find angle C2. 180 minus 85 minus B2. $180 minus 85 minus 131.656. Minus previous answer. And we see we get a negative. What was it? I already forgot. Negative 36.656. This angle should be positive for there to be a second triangle. Since this is negative, there is no second triangle. Find all possible triangles if one side has length of 4, opposite an angle of 50 degrees, and the second side has length 10. So draw a triangle. I'm going to label it A, B, C. So I'm going to say the given angle is A, 50 degrees, because I can. Opposite side length 4, and a second side length 10. So it doesn't matter. I'm going to put it as B. All right, my given information, angle A, side A. And I have enough information to find angle B. Again, always do this with the assumption that you have two triangles. So we're going to call it angle B1. Sine 50 degrees over 4 equals sine B over 10. Cross multiply. Divide by 4. And take the inverse. Calculator. Sine 50 over 4. And you can see that it says undefined. You're going to get an error. when you see that, this means there's no such triangle. And here's why. When you're dealing with a sine ratio, sine theta equals opposite over hypotenuse. Your hypotenuse has to be the biggest side. So when I'm doing this ratio, 10 sine 50 degrees over 4. I already know it's over 4, so we're going to do 10 sine 50 in my calculator. And we get 7.7. Well, if we look at that ratio, 7.7 is bigger than 4. But that's supposed to represent the hypotenuse. It's not bigger than 7.7. No such triangle. Solve triangle ABC if A is 36.9 degrees, side A 186.2, and side B 246.3. Draw a triangle. A, B, C. Label. Side B. We're going at it with the assumption that we have two triangles. We're going to prove otherwise, or either prove that it exists or prove that it doesn't. With the information that I have, I know side A, or angle A, and side A, and I've got enough information to find angle B. Since we're assuming there's two triangles, we're going to call this angle B1. Start with what we know. Sine 36.9 degrees over 186.2 equals sine B over 246.3. I had this question come up in class. It is 100% coincidence that we keep solving for angle B first. It just happens to be how we do it. Divide. Then inverse sine. Calculator. To 46.3 sine 36.9 over 186.2. 52.582. All right, now, next one. We've got this angle. Now I have enough to find angle C. Under the assumption that this is my first triangle. 180 minus the given angle minus my 52.58. Calculator. Use that previous answer. I think that helps with your rounding. So 90.5. 90.518. Now we find little c. Given sine 36.9 degrees over 186.2 90.518 degrees over little c. Divide. And then calculator. $186.2 sine previous answer over sine 36.9. 310.103. All right, now we're gonna draw a box. Anything we do in that box represents our possible second triangle. All right, we started with angle B for the first triangle. We're gonna start with angle B for the second one. So angle B2 equals 180 minus B1. So 180 minus 52, and I'm just going to copy down when I see 5, 8, that's a lie. That's right, 5, 8, 1, 5, 127.419. Find angle C2, 180 minus the given, and it's going to bother me that I use the same color. Minus your new B2. Minus 36.9 minus the previous answer. It's little, but it exists. 15.682. So that's positive, which means we do have a second triangle. All right, so sine 39.6 degrees over check and make sure that's what I typed in the calculator. Yep, we're good. Over 186.2 equals sine 15.682 degrees over little c. I'm writing too small. All right, we'll divide sine 36.9 degrees, little c. Calculator. Sine of my previous answer over sine 36.9. So 83.821. All right. We go at the law of sines ambiguous case with the assumption that there is a second triangle. So I have shown you an example with two triangles. I have shown you an example with one triangle. I have shown you an example with no triangles. I've showed you one of each type. All right, now, I know in every single one of these examples we solved for angle B first. That's not how it always works. It just happens to be what worked in this. You can read all this if you want to. This is a new way, another way of finding an area when you don't know height. Because the area of a triangle is 1/2 base times height. We're not going to know this piece. Okay, so the law of sines creates a relationship in there that we can use to plug in and find area without knowing the height. Okay, so there's 3 different variations of it, and they all do the same thing. All right, so if I draw a triangle, maybe. Okay, and let's say I know this angle, and I know this side, and I know that side. Okay, so I could find the area of this triangle by doing 1/2 side I know, other side I know, times the sine of my angle. Okay, that's what all this is. All right, I've got 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. So you can notice that the angle here is the missing letter. Angle here, missing letter. Angle here, missing letter. And that's because these angles are between the 2 sides. So the area is 1/2 of the product of the sides and their included angle. Find the area of a triangle given beta is 42 degrees, A is 7.2 feet, C is 3.4 feet. Found the area to the nearest tenth. All right, so we have angle A, B, C. Angle B is 42 degrees. Side A is 7.2. Side C is 3.4. I have an angle and the 2 sides around it. So 2 sides, included angle. And I can tell that from the letters because I have a B, an A, and a C. So then the area of that triangle equals 1/2 side that's next to, other side that's next to, sine of your angle. Calculator. One half, oops. A, B, sine C. And I say A, B, sine C, that's how I learned it, but it's just side, sine of your angle. Which is 8.190. And we'll do round to nearest tenth, so 8.2 feet squared. There's nothing too ambiguous about using this area formula. You plug in and you go. Our remaining 2 problems are application problems. We'll find the altitude of the aircraft. This is my altitude. I'm going to call it X because I can. All right, that altitude makes a 90-degree angle with the base, which is 20 miles. I have the base. I need the height. I don't have that. But what I do know is this angle from the satellite to the plane is 15. And this angle from that satellite to the plane is 35 degrees. And I know this distance. So what we have is angle, side, angle. All right, so I'm going to manipulate it so that I can find the altitude. And given that I have angle A or side A here that's already drawn, I'm going to find that. First thing I want to do is find that plane angle. So 180 minus 15 minus 35. $130. That gives me an angle and its opposite side, and I can use that with that 35-degree angles in side A to find side A. Law of sines, sine 130 over 20 equals sine 35 over A. We just cross multiplied, and now I'm dividing. Calculator. Sine 35 over sine 130. We get 14.975. The reason I wanted to find that is because, let's use blue. That gives me a right triangle I can use. So you can see that right triangle coming in here. Side length. There's my 90 degrees and a hypotenuse. So I'm gonna draw the triangle. We know this angle, 15 degrees. We're missing the altitude. We know it's 90 degrees right there. Is 14.975. I have a sine function here. Opposite over hypotenuse. So sine 15 degrees. Opposite, that's a lie, over hypotenuse. Okay, we're going to multiply both sides by 14.975. Calculator. Okay, I'm going to use previous answer times sine 15. I'm going to get 3.876. Use your units, miles. Similar problem here. Different setup, but similar problem. I have an airplane that's sitting right here. And we're supposed to find the altitude. Make sure you follow directions in feet. And our measurements are given in miles, so we're going to have to do a conversion there. I want to know that distance. All right, again, I'm going to call it X because I can. So I have depression angles on either side. Those are congruent with your elevation angles. 28 degrees angle A, 45 degrees angle B. Right now, with what I have angle, side, angle. We can use the law of sines to find one of our missing side lengths over here. Okay, I'm going to find side B. To do that, I need this angle. I need the plane angle. Well, 180 minus 28 minus 45 degrees. And 45. 107. Okay, well, my given information, 107, 6.2, and I can find 45 to side B using the law of sines. Sine 107 over 6.2 equals sine 45 over side B. Cross multiply. Divide. Calculator. Sine 107. 4.584. And that gives me a right triangle to work with. I want to draw that right triangle. For me, it helps me. 90 degrees. That angle is 28 degrees. Hypotenuse is 4.584. And we're finding the altitude. So sine 28 degrees, opposite over hypotenuse, multiply, calculator, I already have the previous answer, so I'm going to answer times sine 28. 2.152. That's in miles. And the answer is supposed to be in feet. So I'm going to take this 2.152. We're going to multiply it by 5,280. That's the conversion for feet. Previous answer times 5,280. So 11,363.8. 363.8 feet. Make that actually look like a comma. Come on. And there we go.